Okay, so we're continuing with coordinate geometry, and there are a few different things and formulas that you might want to know for the exam, and we will start with distance, and that's between 2 points. And to explain this, I'll put up some axes, do a point here and a point here, and we want to find this distance here. And notice what I've kind of done here. I've kind of formed a bit of a right-angled triangle, and so that should instantly make you think Pythagoras. And we're thinking a squared plus b squared equals d squared. And let's call this point A and point B, or point 1 and point 2, maybe. Let's do point 1 and point 2. So that means this bit here is going to be at x2. This bit here will be y1. This bit here is x1. And this bit here is y1. So how do we, and let's call this A and let's call this B. How do we find A and how do we find B? Well, we can just take this distance minus that distance, right? And that would be x2 minus x1, right? Now B, we'll do the same thing. It'll be y1 minus y2. And I just want to first say, what if we did y2 minus y1? Well, what we would get is actually minus b, right? And because we square that, that gets rid of the negative. So we'll say that b, or at least the absolute value, which means distance from 0. If it's a negative, you still make it positive. We'll just do these absolute values just to be pedantic. Because the point is, even if what's in the bracket getting squared is negative, doesn't matter, because negatives squared are positive. And so that's how we can get the D is root of y2 minus y1 squared plus x2 minus x1 squared. And also, if you're talking specifically about something on a graph, on a line, on a straight line on a graph, that would be called the length of line segment. Now, line segment is the bit of the line that's between two defined points. If you just got 1 point and it goes out the other side, on one side, that's a ray. And if it's just the whole line, negative infinity to positive infinity, it's just a line. So that's distance. Quite easy, just uses Pythagoras. One thing you might be able to do, might get an exam is, maybe they'll give you 1 point, they'll give you a gradient of a line that's on, and they'll give you the distance to a second point. And you've got to find like the two possible second points that it could be. Something like that. And that's why I recommend, yes, it's good to just think, Pythagoras, and that's very easy if you just get asked for distance, but I do recommend you have this formula down pat so you can use it, because it will make the algebra simpler, because you need it down so you can do the algebra and work out harder problems. The next thing we will do is midpoint. This is an easy one. This is the easiest one. Say we take 2 points, one and 2. This is x1, and this is x2, and this is y1, and this is y2. How would we get in the middle here? I think that roughly looks like the middle there. Well, that low-key looks like it's halfway between y1 and y2, and halfway between x1 and x2. And funnily enough, it is. So the midpoint of, technically we should write midpoint of AB, or whatever, or something. Well, in general, midpoint equals x1 plus x2 over 2, and y1 plus y2 over 2. And if it was like a line between the points A and B, I'd call it big M, little AB, or something like that. So that's an easy one. But again, you might have to use that formula in some algebra of a more complex problem. Generally, I'd say what you might get with that one is like, you're given several points, and you say, oh, this is the midpoint of that, and that's the midpoint of that, and there's lots of them, and you've got to work a bunch of them out. There are a lot of different possibilities with coordinate geometry, and sometimes it is the hardest questions in the exam, especially when we get to circles. But it'll make, the things I'm saying now will make sense when we get to some practice problems in another video. So those are two important things about what you might get with points and lines. And now we'll move on to some more actual type questions that you might actually get. Well, no, I mean more heavier content, slightly. The next one I'll say is intersections. This, if it asks for the points of intersection, you got to instantly think simultaneous equations. Now, I assume you might know linear. So, for example, something like 2x plus 3y equals 9, and 3x plus 5y equals 13. Just a reminder, you would multiply that out. 6x plus 15y equals 9 times 3 is 27. Then this would become 6x, 10y equals 26. See, what we're doing is we're multiplying everything by a common we're multiplying everything both in an equation, both of them, by numbers that will get them to be a common multiple. So that way we can eliminate, this is why it's called the elimination method, those two 6x's and only get y's. So we get 5y because 6x minus 6x is 0. And that gets us 1. Y is 1/5. And then we would substitute back in. So 2x equals minus 3y plus 9. So it's minus 3/5 plus 9. And then we'd divide that by 2. So that's, what, 8.4 over 2, which is 4.2, which is 4 and 1/5. It's 21/5, I think. Doesn't matter. You could have done a mixed fraction as well. So if it asked, okay, what is the point of intersections of 2x plus 3y equals 9 and 3x plus 5y is 13? You'd say point of intersection is 21 over 5, 1/5. Additionally, it could have given you something like this. And what you would do here is just you set them to equal each other. And then you get 4x minus 3x is x minus 3. So x equals minus 3, then y equals 4 times minus 3 plus 1, which is minus 11. So intersections at minus 3 minus 11. And those are easy ones because they're linear. It's a bit harder if maybe one of them's non-linear. So you got something like y equals 3x minus 2, and then suddenly you got thrown x squared plus y squared plus 6x minus 8x plus 25 equals 0. Sorry, 8y minus 8y. You're given that. What you would do is something, you can't eliminate that because you'd have to square things and then you get worried, then you can have fake solutions or completely ignore solutions. So what we are going to do is a substitution. We know y, so we can just replace every y with 3x minus 2. And then if we expand this, that becomes 6x squared minus 12x plus 4 plus 6x minus 24x plus 16 plus 25 equals 0. So that would be 7x squared. So that's minus 30x. 20 plus 25 is plus 45 equals 0. I don't know if that factorizes or not. We could certainly go about in solving that, but essentially you would solve that and you'll probably get two answers. So you'd have to individually put them back into 3x minus 2 to get two different y values, and then you would give 2 points of intersection. And it may even be simpler than that. So if you had 3x minus 2 and y equals x squared minus 9x plus 11, you'd set them to equal each other. X squared minus 9x plus 11 equals 3x minus 2. Then you'd do this, and then you'd solve. And again, I don't know if that factorizes or not. But you'd solve that, get your two possible x values, put it back into y, and then give you 2 points of intersection. So that's for intersections. Think simultaneous equations. You can eliminate like this. You can just literally set it to equal each other and rearrange, which is a form of elimination, kind of. And then a substitution. That's the other one. Now, the next thing we will talk about will be in the next video, and that's to do with parallel and perpendicular lines.